नवाल, आपका ये कब है, एग्जाम कब है? डू यू हैव हाफ ईयरली या फिर कुछ यूनिट टेस्ट वगैरह?
Yes, it's on 13th October.
14th of October for chemistry.
13th.
13th of October. Can you send me the syllabus and the date sheet? Because याद रहेगा हमको. I don't have to ask you daily. ठीक है. Send me
Yes.
the syllabus. What you marked in your form that day is solution, electrochemistry, haloalkane, halorenes, alcohols, phenols, and ethers, and biomolecules. Is that the
Yes,
same
sir.
syllabus?
Yes, sir.
Nothing extra, nothing, no addition or subtraction from here. Solution, electrochemistry, haloalkane, halorene,
Yes.
alcohol, phenols, and ether, and bio. Okay. So I think biomolecule is the one that we have not covered at all, right?
Yes, sir.
And Hanifa, for you. Okay. Hanifa, आज आपका एग्जाम था क्या?
Yes, sir. I had psychology.
You had what?
Psychology.
Psychology.
Yeah.
Oh no. Psychology. When is chemistry for you?
This Thursday.
This Thursday. And the chapters that are coming are okay, wait a second. Solution, electrochemistry, haloalkane, halorene, alcohol, phenols, and ether. Right.
There's just two alcohols and electrochemistry.
Alcohols and electrochemistry. Okay, fine. I think you people are not also you people are also not going to have any half yearly exam, right?
Next month I do in November.
Okay, so see, if you're having a bit of struggle here, then there are only basically two reactions. Sorry, there are only two equations that you have to remember. The two reactions are Q is equal to what? IT, and there is Q is equal to the delta OS into moles. Whatever number of moles you're going to calculate. Okay. So these are the only two equations. Delta OS you will get from reaction. You have to write the reaction and then plug in the delta OS, change in oxidation state. First of all, you have been given what? Calculate the strength of current required. That means you have to calculate I. The T has been given. And magnesium, you have to get magnesium from molten MgCl2. That means you will write the reaction, get the oxidation, change in oxidation state of magnesium, then how many moles. So first of all, then you have to calculate the number of moles of magnesium from 1.2 grams, right? And then you multiply the number of moles into change in oxidation state, you will get the Q. You will get the Q, right? Time has been given. You will get the Q from here, and you can calculate for I. Now, these are the easiest questions that you can get in electrochemistry chapter. And also, this is not for 1 marks, even though everything is so simple, it is of 3 marks. Okay. So, like electrolysis is conceptually a bit tough. Starting with electrochemical cells, these are very straightforward. But okay, Rifat is here today. I think Rifat had some exam. Try कीजिए इसको. Okay, so even if you don't get the answer, there are a few things that you should send me in WhatsApp. First of all, what is the reaction that is taking place? Second, Okay, second is the number of moles of Mg that we require. That means 1.2 gram में कितना number of moles होगा. At least if you have these two things, then it will be very easy. Try to get these two things from the question. Assalamu alaikum Rafat, how are you? Rafat, am I audible?
Yes, sir.
Yes, okay. आप कल नहीं आई थी ना?
No, sir.
अच्छा, जुमे के दिन, Friday?
हाँ, I joined Friday.
Friday you joined. So today we are going to like towards a new topic. तो कल की लेक्चर की जरूरत नहीं है आज के क्लास के लिए, लेकिन आप उसको देख लीजिएगा, है ना? आज वो अपलोड हो गया होगा मोस्ट प्रोबेबली, एंड डू वॉच दैट लेक्चर, दैट इज इम्पोर्टेंट. वहां से सवाल आते हैं काफी.
Yes, sir.
अच्छा 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 अच्छा. Okay, okay. We'll see, we'll see. You have given the reaction, that is very good. And then you have also calculated the number of moles. क्या आपने calculate? अच्छा, उस तरह से आपने किया question. Okay, okay, Hanifa. What about, okay, Nawal got disconnected. Okay, fine. Let's do this question. So first of all, what is happening here? Moles of Mg will be equal to, now, I mean, as you can see, they have given you the atomic mass. Okay, so generally they give you atomic masses in CBSE examinations, but you never know. So atomic masses na revise करके ही जाने से भलाई है. 1.2 grams divided by 24 grams per mole. Okay, this is my number of moles, and what it is saying, Mg2 plus will be there in MgCl2. It will eat up 2 electrons, and it will get converted to mg, right? Now, what is the Q required here? The Q required here is equal to change in oxidation state is 2 multiplied by the number of moles, that is equal to 1.2 upon 24 grams per mole. This is 2F. That means Q will be equal to 2 into 96500 into 1.2 divided by 24. Right? Divided by 24. Then we have another equation. Q is equal to IT. So from here, I need to calculate what? The strength, I. So I will be equal to Q upon P. So this will be equal to 2 into 96500 into 1.2 divided by 24 into 1 hour means how much seconds? 60 minutes into 60 seconds. Then you will get the answer in what? Answer in terms of ampere. Okay, so convert the hours into seconds. Once you calculate this, this will be gone. Then this will be 12 and this will be what? 10, right? So we are going to have this is equal to 965 is remaining above. Here we have 10 into 6 into 6 ampere. Hanifa, आपने 24 तो ठीक है. Why it is 1 up? Okay, 1 upon 10 is because of the number. Okay. Why do we have 1 upon 10 there, Hanifa? 2 into 96500 divided by 24. So 2 I understand. Hanifa, tell me.
The decimal for 1.2 I can verify.
अच्छा 1.2 को आपने वही हम सोच रहे 1.2 भी है वहाँ पे तो अच्छा 10 भी. Okay, fine. So we have written okay. अच्छा आपने फिर इसको 1 से डिवाइड कर दिया टाइम में, है ना? टाइम में बस आपका चेंज करना पड़ेगा, आई थिंक, राइट? अदर थिंग्स आर फाइन. 965 या करेक्ट. देखिए आपने क्या लिखा है, I is equal to Q upon P. Q आपने लिखा है 9650 divided by this is 1 hour. Now you just convert this 9650. 1 hour can be written as 60 into 60 seconds, right? Now once you दोनों बराबर है, दिख रहा है आपको? 60 को क्या लिख सकते हैं हम लोग? 10 into 6 and we have this 6 also, right? So your answer is correct. You just needed to convert this hour into second. Got it, Hanifa?
Yes, sir.
Okay. So now let us move on to the next topic, right? Conductance. Conductance. Okay. See, you must have also learned conductance in your 12th standard physics, right? And उससे पहले जब आप लोग 8th standard में, first of all, when you were learning about metals, then you would have known that one of the properties of metal is that they can conduct electricity. Now there are two types of conductors. Please write the first line. There are two types of conductors. Number one that you are well acquainted with is metallic conductor. The second one is electrolytic conductor. Second one is electrolytic conductor. First of all, let us look at the similarities and the differences. What is the similarity between both of them? One thing about whenever you are asked to गेट द डिफरेंसेस ना, उन दोनों के बीच में कुछ ना कुछ सिमिलैरिटी होगी, तभी आप डिफरेंस बता रहे हैं. If both the things are completely different, then you will never talk about the differences. Okay. Now, since both of these are conductors, then only we are pointing out the differences between these two conductors. Okay. Like whenever I write the differences between two things, I usually find myself thinking, what is the similarity here? Because until and unless we have similarity, there will be no differences. Okay. So not a good thing. I will draw it like this. A few of the things you must be knowing. Few of the things you may not be knowing about the differences. So point everything out. This is the middle. It's kind of like the middle. Okay. So right here, a metallic conductor. Electrolytic conductor. Write the number 1 point. Now, in metallic conductor, what is the charge carrier? What is the charge carrier? These are electrons, right? So the current flow in one direction, and the electrons are moving in other direction. Now here the charge carriers are ions. The electrolytes are the charge carriers, Zn2 plus, copper 2 plus. These are the ions which are carrying the charge, and they are carrying the current. Now, whenever you are going to flow some current through a metallic conductor, it is not going to show any change in chemical composition. Okay, copper wire से अगर electricity pass करिए तो copper wire ही रहता है. So right here, no change. In chemical properties. Is seen when current is passed. Okay. But here, what do we see? When the current is passed through an electrolyte, decomposition happens, right? So right, it involves decomposition of electrolytes. It involves decomposition of electrolytes on passing of current. Okay. Now, once we pass current through a metallic conductor, the mass of that metallic conductor, that if it is a copper wire, the mass of copper wire is not going to change. But we know that when we are passing electricity through an electrolyte, some of it will be getting decomposed, right? When it is getting decomposed, and it involves a transfer of mass also, from either from the rod to solution or from solution to rod. Right, the next point. Metallic conductor does not involve transfer of mass. This involves transfer of mass. Okay, now the next point, आप लोग हमको बताइएगा मेटालिक कंडक्टर के बारे में, ठीक है? conductance dash increases or decreases on increase in temperature. बताइए. Hanifa, Nawal and Rifat, tell me. In metallic conductor, what happens? When I increase the temperature, conductance increases or decreases? आवाज नहीं आई रिफत आपकी. चैट में भेज दीजिए रिफत.
Decreases.
Decreases. Okay. What about you guys? Hanifa and Nawal.
Yes.
Yes, Hanifa.
Decreases.
सही है. Correct. The conductance it decreases here. क्यों डिक्रीज करता है मेटालिक में? I mean, I don't know. I mean, हम अगर याद भी होगा तो हम भूल चुके हैं. I don't remember actually like why it decreases. ज्यादा पता है आप लोग को? रिफत, नवाल, हनीफा, anyone?
Due to increase in resistance.
Why does resistance increase with temperature then? The conductance का तो उल्टा है ना resistance. Okay, fine. Can we go a bit one more why, Hanifa? No idea.
No, sir.
Okay. Oh, okay, fine. Okay. So actually what I just said is that when I am going to increase the temperature, then what is going to happen? For example, there are two types of vibration that are happening. If I have a conductor which is metallic, then there are electrons like this which are moving, right? The electrons which are moving. And then if I write this as big thing, these are the atoms of, let us say, copper. Now, when the atoms of copper are moving and the electrons are also, because if I increase the temperature, then what will happen? Atoms will also start to vibrate. Correct? Now, this vibration of atoms, it kind of does what? It kind of creates a hindrance for the movement of electrons. Okay, so when atoms are vibrating in a very, what can I say? when the atomic vibrations are very high and they're vibrating very fastly, then it creates a hindrance for the electrons to move. That is why when we increase the temperature, then there is a decrease in metallic conductance. Okay. Now, what about the electrolytic conductance? Electrolytic conductance, I think it is very logical to say that here, since those ions, those atoms which are having some positive charge, those are the things which are moving, right? We have Zn2 plus and copper 2 plus. Those are the things which are moving and carrying electricity. So if I'm going to increase the temperature, then they are going to move very fastly. And when they are going to move very fastly, the current and the electricity will be passed on very quickly. That is why it increases with increase in temperature. Done, everyone is able to see me? Wrote both the points?
Yes, sir.
Okay. Achha. You guys know about these two type of electrolytes, right? Strong and weak electrolytes. Right, guys? Yes or no, please tell me.
Yes.
Right, okay. Then I can directly move to the factors affecting electrical conductivity of the electrolytic solution, right? You can directly move on to that part. Please write factors affecting okay, just a second. Before going to that part, now wait a second. Don't write that part. Let us just revise a few things about conductance and resistance and these type of things. Right here, conductance. What is conductance? Please write. Property of a substance. Property of a substance which gives an idea about the flow of electron, about the ease of flow of electron, and is measured as the reciprocal of resistance. So conductance, it is shown by G, right? G is equal to 1 upon R. What are the units? Unit will be ohm inverse, we can write. What else we can write? It is also written or MHO, mho. There is also one more unit, which is Siemens. Right, next, conductivity. This conductivity, a reciprocal of resistivity. Reciprocal of resistivity. And how do we write conductivity? We write it as kappa. Right, something like this. This is equal to 1 upon rho, which is resistivity. Now write the next one, relationships. So if we can calculate and we can determine the relationship between the rho and resistance, then we can also determine the relationship between conductance and conductivity. So since resistance is directly proportional, this is rho, and it is directly proportional to the length and inversely proportional to the area, right? Then we can write what rho is equal to. Rho is equal to, we can write this here we will be getting R, and the reciprocal will be A upon L. Correct? Now, what will be kappa? Kappa will be equal to 1 upon rho. Right? Kappa will be 1 upon rho. So this will be 1 upon R into A by L. What is R upon R into A by L? R into A by L is equal to resistivity, right? So conductivity is reciprocal of resistivity. Then we can segregate this to 1 upon R into this L will go above, you will get L upon A. Right? You are going to get L upon A. What is 1 upon R? This is conductance. L upon A is known as cell constant. Oh my God. Cell constant. It is the ratio of length upon area. Right? What is L? Now, in the case of electrolytic cell, here we are going to have L is the separation between electrodes. And the area is going to be the cross-sectional area. The cross-sectional area of electrode. Write a point. Cell constant is independent of concentration. Independent of concentration. Right, next point. The conductance offered by unit volume of conductor is called conductivity. Now, this is a very general thing how we define the constants. So whenever something is constant, we have what? Kappa is equal to 1 upon R, right, into L upon A. Now, what are the things which are independent? We can have cells of different length and cross-sectional area. Now, if I have area is equal to 1 centimeter square and the length is equal to what? 1 centimeter. Right? So for this particular cell, the volume will be equal to 1 centimeter square area into length. That is going to give you the volume, right? What is this? A cube? How it is A cube? If I get the area of this area is A square. And this height is going to be A. If you multiply the area into height, it is going to give you what? The volume. So here the volume is going to be 1 centimeter square into 1 centimeter, which is going to give you 1 centimeter cube, correct? And this 1 centimeter cube. Now, if I plug that value, so kappa will be equal to 1 upon R, that is equal to G, conductance, right? So kappa, conductivity, is the conductance when the conductor is of unit volume. When the conductor is of unit volume. That means from here you can say for a 1 centimeter cube of solution, conductance is equal to conductivity. Similarly, for a V centimeter cube of solution, 1 centimeter cube में solution है हमारे पास, similar to conductivity, जो conductivity है वही. If I have 2 centimeter cube of solution, then it is going to give me twice of conductivity. If I have 3 centimeter cube, it is going to give me thrice. If I have V centimeter cube of solution, then the conductance will be equal to kappa into V. So from here we can get formula: conductance is equal to kappa times the volume. Please remember that volume is in 1 centimeter cubes, okay? V is volume of solution in centimeter cube, or we can write ml. 1 centimeter cube is equal to 1 ml. Is everyone done?
Done.
All right, next. Molar conductance. Right here. Molar conductance. Molar conductance, or it is also known as molar conductivity. Right here. Conductivity. Now this has been represented as lambda m, or the big lambda. This is lowercase lambda, this is uppercase lambda with a subscript of m. Please write the conducting power of cell, sorry, the conducting power of ions produced by one mole of electrolyte in a given volume of solution. It's called molar conductance. Done, guys? Yes or no? Please tell me. Done, everyone? Yes or no?
That's
Okay. That means the conductive power of ions produced by 1 mole of electrolyte. By 1 mole of electrolyte. Okay. So we know that conductance is equal to what? Conductance is equal to kappa into the entire volume. Kappa into entire volume. Now we want to get what is the volume? What is the volume that is taken up by 1 mole of electrolyte? So please write volume taken by 1 mole of electrolyte. Volume taken by 1 mole of electrolyte will be equal to what? If, for example, the concentration is having 2 moles per liter. 2 moles per liter. That means 1 mole कितने के अंदर में होगा? 1 mole will be in 0.5 liters. Yes or no? Please tell me, guys. 1 mole of electrolyte will be in 0.5 liters. Correct? Because in 1 liter, what does 2 moles per liter mean? It means that there are 2 moles in 1 liter. That means 1 mole in 0.5 liters. Yes or no? Please tell me, guys. Correct है? नहीं. Oh my God. हाँ याना जल्दी बोल दीजिए. Hanifa, Nawal, and Rifat. Do you agree with this statement? No. Doesn't make sense. What about others? Hanifa and Nawal. Does this make sense?
Yes, sir.
Yes, no. Confirm. Right. See, volume will be number of moles is equal to the molarity upon volume. Correct? Molarity upon volume. Now, if I want to calculate the volume, it will be upon what? Molarity upon the number of moles. ठीक है? तो इसी तरह से अगर आप यहाँ पे देखिए, we have here volume taken by 1 mole of electrolyte. It will be equal to your volume 1 liter divided by the molarity. है ना? अगर आप याद कीजिए 2 moles per liter, that means 2 mole in 1 liter. That means 1 mole in 1 liter by 2. तो हमने क्या लिखा? मोलारिटी लिखा, डिवाइड के मोलारिटी से, and what is in the numerator? It is 1 liter. But since we are having and dealing with only mls, this will be what? 1000 ml per whatever the molarity is. This is going to be the volume that is taken by 1 mole of electrolyte. And from here we can write the molar conductivity lambda m, or if you write it as capital, this is going to be equal to kappa into 1000 divided by molarity. Done, guys? Yes or no? Please tell me.
Yes, sir.
Now, right, factors affecting molar conductance. Right, number one. Nature of electrolyte. Nature of electrolyte. That means if the molar conductance of, like if I have a strong electrolyte, then its molar conductance will be higher. If I have weak electrolyte, then we'll be having molar conductivity, which is going to be lesser. Right here, the molar conductance of strong electrolyte is higher than the weak electrolyte. Because strong electrolyte dissociates almost completely. And the second one, size of ion. Smaller the size of ion, greater will be ionic mobility and higher will be the molar conductance. Third point, temperature. The interionic interaction decreases as the temperature increases. And when ions are not interacting with each other, they will be free to move. And that is why the ionic mobility will increase, and hence the molar conductance will also increase. Right? Next, when temperature increases, interionic interaction decreases as the temperature increases, due to which ionic mobility increases and lambda m increases. Right, the fourth point. Now this is something not very intuitive. Concentration. Okay. Now the molar conductance is going to decrease when we are increasing the concentration, because if you look at the formula here, lambda is inversely proportional to the molarity. So if this molarity is going to increase, lambda m is going to decrease. Okay. That is why, right, next for concentration. We'll write it like this: when the solution is diluted, the lambda m of electrolyte increases, because with dilution dissociation of electrolyte increases, because with dilution the dissociation of electrolyte increases. That means lambda m, I can write it is directly proportional to dilution. Lambda m is inversely proportional to concentration. Okay, this is very important point. Then guys, just now please tell me. Okay, related to this, there is a concept which is known as infinite dilution. Infinite dilution. Please write. This means the solution is so dilute that lambda m, that means molar conductance, attains a maximum, or we can also say a limiting value. That means that is the limit of molar conductance. It cannot go higher than that. Okay, it cannot go higher than that. Maximum or limiting value. And do not increase on further dilution. Because of infinite dilution, dissociation of electrolyte is 100%. Now write a note. It's very important. Okay, it's also very important. When solution is diluted, number of ions per unit volume decreases. Therefore, hence, conductivity Okay, please remember conductivity and not molar conductance. Conductivity of solution decreases with dilution. Conductivity of solution decreases with dilution. That means if I talk about kappa, kappa is directly proportional to concentration, and kappa is inversely proportional to dilution. Done, guys? Is no question me?
Dot.
Right, next. Effect of dilution on molar conductance of weak and strong electrolyte. Of weak and strong electrolyte. So first of all, we are going to see the relationship, how the dilution affects the molar conductivity of strong electrolyte. Right, number one, strong electrolyte. Right here. When solution is diluted, molar conductance of strong electrolyte increases slowly. Why it will increase slowly? Because strong electrolyte are almost already diluted, right? Strong electrolyte are almost already dissociated. They don't go further dissociation, right? Because increases slowly because strong electrolyte are almost completely dissociated. Are almost completely dissociated, due to which graph of molar conductivity, the root of concentration is linear. Okay, it is linear. ये ध्यान रखिएगा. अच्छा, डाइल्यूशन का मतलब क्या होता है? कंसंट्रेशन इंक्रीज करना या डिक्रीज करना? डाइल्यूशन का मतलब क्या होता है? कंसंट्रेशन इंक्रीज करना या डिक्रीज करना? वो व्हाट हैपेंड गाइस? डिक्रीज करना, ठीक है ना? हाँ, ये ध्यान रखिएगा. डाइल्यूशन का मतलब होता है कंसंट्रेशन डिक्रीज करना. I mean, I'm saying that because जो ग्राफ है ना, like we have a habit. If I write the concentration like this, it is between the root of concentration and lambda m. Then we have a habit of reading the graph like this. Okay, but in this case, you have to read the graph like this rather. We are decreasing the concentration. Concentration 0 की तरफ जा रहा है ना. We are diluting it. So when we have some concentration here, right? When we have some concentration here. Now, when I am going to decrease the concentration, that means increase the volume, then what is going to happen? When I'm going to increase the volume of the solvent, then what is going to happen? The lambda m is going to increase. It increases with dilution. It will increase slowly, and it will reach a limiting point. And that limit is what? The highest molar conductance, which is lambda m at infinite dilution. देखिए आप concentration कितना हो गया? 0 हो गया, right? So this is the lambda m at infinite dilution. Right? The above graph. The above graph follows. ये दो आई नहीं है भाई, ठीक है? This is u with 2 dots. आप ऐसे लिख लीजिए. D by Huckel equation. ये हकल पता है कौन है? Who is this Huckel? Aromaticity वाला हकल है. D by is another scientist. Now they have said that the lambda m at any concentration, it will be equal to lambda m at infinity minus b into root of concentration. Okay, so this is your y. No, sorry. This is your y. This is your c. Minus b is your m. And this is your x. So y is equal to mx plus c. Right, next. The constant b. The constant b depends on the charge and temperature. Charge on the electrolyte, okay? 2 plus 3 plus on electrolyte. Done guys, this one please tell me.
Then
Okay. Right, next, the B part, which is weak electrolyte. Achha, by the way, just telling you, this part of this graph, na, that means this molar limiting molar conductivity. So zero concentration में तो कुछ तो molar conductivity होगी नहीं, right? So we get this delta m by extrapolation. How it is done? Let me show. For example, I will get the graph till here. I will get the graph. Some measurable quantity of electricity will be flowing till here. Okay, let us suppose that till here there is some limit, some electricity flowing. After that, we are not able to measure the electricity. Then we can get this particular graph by extrapolation. Okay, so we can get this delta m by extrapolation. So by extrapolation. Right, next B part, weak electrolyte. Right. And solution containing a solution containing weak electrolyte is diluted, then the molar conductivity increases very sharply. Increases very sharply. Why does it increase very sharply? Because the weak electrolyte is only partially dissociated, and as dilution increases, the electrolyte dissociates rapidly. Hence, the graph between molar conductivity versus the root of concentration is not linear. So here we have lambda m. Here we have the root of concentration. Sorry, guys. Just a second. Yeah. ये सर्कल मत बनाइएगा प्लीज. So you can see that it increases like this. You can see that the increase is very steep. I mean, it is a bit more steep. You draw this graph. I'm seeing if I can make something more steep. No, I don't think so. I think it is more steep, right? Is it? I don't think so. It is more steep. I'm going to increase this thing, then it is going to cover this only. No use. Done, everyone is on, please tell me. Write a question. Lambda m of 1.5 molar solution of an electrolyte is 138.9 Siemens 138.9 Siemens centimeter square mole inverse. We calculate the conductivity of this solution. So how are we going to do this? What is the relation between lambda m, what we have given? Lambda m has been given, right? And we have been asked about conductivity. So we know that the relationship is lambda m is equal to kappa into 1000 divided by whatever the molarity of the solution is, right? So very direct question, you can write here, what is kappa? Kappa will be equal to the molarity into lambda m divided by 1000. What is the molarity of the solution? It is 1.5, the concentration, into lambda. Oh, molarity is given. Yeah, molarity is given. Okay, right? And lambda m is equal to 138.9 divided by 1000. What will be this? यहाँ पे पहले देख लेते हैं. This 1.5 is moles and 138.9 is having a unit of Siemens centimeter square mole inverse, right? Siemens centimeter square mole inverse. Now, what is this 1000? This is mole per liter. What is this 1000? 1000 represent that 1000 centimeter cube is present in 1 liter, right? We are just dividing this by 1. 1000 centimeter cube or 1 liter, it's the same thing, है ना? तो हमने वो इक्वेशन लिखा था, वहाँ पे we have added 1000 because we are just converting centimeter to liters, nothing else. You can see that we can cancel a few things. Liter inverse and liter inverse will get cancelled. Mole and mole will get cancelled. A centimeter cube, it will go above and it will become what? Centimeter to the power. Now this will become -3. So your answer is going to be in Siemens per centimeter. What is the value that you are going to get? Just multiply this number 1.5 into 138.9. तो आधा कितना हो जाएगा? If I take this as 139 into 2, 306 and 7, 202, 278, and 140 का आधा कितना हो सकता है? 69 minus 69. So will be equal to 27 minus 6 is equal to 21, right? And this is -1, so 219. This will be 21993 divided by 1000 approximately. Okay. That means 0.219. Tell me, is this right? Yes or no, please tell me.
Yes, sir.
Oh, wait a second. No. This will 210 minus 1. This will be 209. Sorry, this will be 209, not 219.
207.
Sorry,
I got 0.207.
0.207.
7. Yes.
Calculator is saying 208.35. Okay. Why you are getting that much? अगर आपने सही से calculate, I mean, I have not taken 138.9 एक्चुअली तो 139, और फिर उसका आधा हमने कर दिया और वो भी 140 लेके आधा कर दिया. Okay. Whatever we are getting, we can approximate it to 2.1. Right, we can approximate this to 2.1 Siemens per centimeter. Got it, right? So please tell me. All right, another question. रेजिस्टिविटी, कंडक्टिविटी, अगर आपको रेजिस्टिविटी मिल जाए तो कंडक्टिविटी भी मिल जाएगा. दैट्स नॉट अ इशू. एंड we have been given a few things. Diameter of the cell is 1 centimeter, so you have to get the area. Okay, so diameter is 1 centimeter and the length is going to be this much. So first of all, get the area of this particular column. So area is equal to what? Of a column is diameter is 1 centimeter and length is this much. So area will be what? Diameter दिया तो pi r square, right? So pi into 0.5 centimeter per square. Calculate the area. And you don't have to do it in decimal point kind of thing, okay? You can just keep it like this, 22/7 into 0.5 square. What will be the square of 0.5? Rather, wait a second, don't write 0.5, write 1/2. Okay, 1/2 ka square. This will be equal to 22/7 into 1/4. So this will give you 11/14, right? 11s are and this 2s are. 7 2s are 14 and 11/14. So like keep it in fractions until and unless you need to convert it to decimal points. So this is your area we have got. What else we need to calculate? The resistivity. Now we can find the resistivity, right? Resistivity, or we can find the resistivity. Rho will be equal to the resistance into, tell me, length upon cross-sectional area. What is the resistance? I think you can do it from here. Resistance आप लोग को दिया हुआ है. Just need to plug in the values.
$5.55.
अच्छा, wait a second. ये हमने गलत लिखा है क्या? L upon E होता है, A upon L होता है.
L upon
L upon A, पक्का? A upon L होता है. This is A upon L, not L upon L. ऊपर क्या लिखा था? ऊपर भी गलत लिखा था क्या हमने? नहीं, ऊपर सही लिखा। Resistance is equal to ये होता है ना?
L upon A ऊपर.
This is right. Resistance is equal to R. ऐसे होता है ना?
Yes, sir.
Right, Rifat?
Yes, no, I'm saying ऊपर we wrote L upon A by mistake. I mean
नहीं,
A.
ऊपर तो हमने यही लिखा था, A upon L नहीं लिखा था, resistivity के लिए देखिए. C for resistivity, what we have written? A upon L.
Yes, sir.
है ना? ये आप लोग मतलब you will be telling me this formula R is equal to rho into L by A. ठीक है, चलिए. So resistivity will be equal to resistance is into A upon L. Resistance is 5.55 into 10 to the power 3. That means 5,500. And here we are having length is 50 centimeter divided by 50. Okay. So 1 0 can be cancelled, and then we have 11 upon 14 there. So this will come out to be how much? More than 100 or less than 100? Let me write it. B, yeah. A is 11 upon 14. And its length is 50. This will be approximately somewhere around between 80 to 90, I think. Calculate this. Even if I cancel this and I make it 10, so 15 by 1000 is
So 436.
आवाज में आ रही है, can you please speak loudly?
436.
400 something. 14 भी है वहां पे, 5 भी है वहां पे. $555 into 11 upon this 87.2. This will be ohm centimeter. Resistivity will be ohm. This will be centimeter square. This will be ohm centimeter. Calculate once again. तो help कर रहे हैं आप लोग.
Sir, I forgot the 5.
I forgot the 5. Okay, okay. So conductivity will be the reciprocal of this, right? Kappa will be equal to 1 upon 87.2. Ohm inverse, centimeter inverse, or we can also write it as 1 upon 87.2. Ohm inverse is Siemens per centimeter. This is your kappa. Now comes your molar conductivity. The kappa into 1000 divided by the concentration. You have been given the concentration 0.05 molar, right? So kappa is 1 upon 87.2 into 0.05. This is into 1000. This will be equal to 1000 upon 87.2 into, this is 5 into 10 to the power minus 2. This will minus 2 will go up, it will become 10 to the power plus 2. We have this. So this is 10 to the power 3 plus 5 upon 87.2 into 5. And what is the unit we are going to get? We are going to get Siemens and inverse, and here we have centimeter cube. This will be Siemens into centimeter cube liter inverse. 1000 का मतलब क्या है? Just 1. And molarity, this is moles per liter. So the unit comes out to be liter inverse will get cancelled. Okay, this is not Siemens, this is Siemens per centimeter. And from here we are going to get Siemens inverse and this. So this is going to be Siemens centimeter minus 2 mole inverse. And centimeter square mole inverse. This is going to be your unit. How much will be this quantity? Uh, 5 8s are. This will be somewhere around how much? Four, 450, if I take 450 and then I have 10,000 upon 45. So it will be somewhere around 200. This value, how much are you guys getting? You will get this value as 230 Siemens centimeter square mole inverse. Okay. So now we have just one thing that is remaining, Colross law of independent migration. That will take around half a class, and then we are going to do some more numericals in the next class. So on next Saturday, this chapter will be completely over. Okay? Electrochemistry will be completely over. Then I think आप लोग के स्कूल में क्या चल रहा है? हनीफा, नवाल, refer tell me guys. जोर से बोलिए, आप लोग की आवाज ही नहीं आती है जी. एक एक करके हनीफा बताइए. केमिकल काइनेटिक्स. तो रिफत आपके यहाँ भी केमिकल काइनेटिक्स?
Yes, sir.
नवाल आपके यहाँ?
Chemical kinetics.
अरे वाह, वेरी गुड, बहुत बढ़िया, बहुत बढ़िया. चलो. So Saturday we'll end this chapter. Next Sunday, chemical kinetics, and chemical kinetics is going to get take even lesser time. It's very small chapter, not very small, but it is comparatively small chapter.